Very good afternoon. Today I will explain the operation of a 12-hour clock made for the digital electronics class. First of all, I will start by showing the operation of each counter made by flip-flops separately. As we can see, here we made a counter from 0 to 9 which will be responsible for counting a part of the minutes of our clock. 4 flip-flops were used because being from 0 to 9, the counter should be mod 10. And as we can know, the number 10 in binary is 1010. So it was necessary this amount of flip-flops. Likewise, we have a NAND gate connected to the first and third flip-flops, and its output is the one that is responsible for doing the reset inside the counter. As we see, this, when it reaches the number 9, is restarted and restarts counting from 0. For the second part of the minutes, we made a counter mod 6. This so that the counter perform its count from 0 to 5. This is because, as we know, within a clock, when we reach 59-hour clock, directly goes to mark an hour and not the 60 minutes. As we see, only makes use of 3 flops since the number 6 is 110 in binary. Only requires the use of 3 bits. Like this, we have a NAND gate connected to the first and second flip-flop to make the restart. In the case of the third hour counter, this is exactly the same counter as the one shown at the beginning, since it is in charge of counting from 0 to 9, and when it reaches this number, it restarts. Therefore, the connection mates for this counter are the same as in our minute counter. In the case of our second hour counter, it is only in charge of counting from 0 to 1, so it was designed to be mod 2 counter. And as we know, the 2 in binary is 10, so our NAND gate is connected to the first flip-flop and will restart before reaching the number 2. When we are making the connections, each counter will depend on the reset of the previous one. But as we know, our clock can only go up to 1259, so our second mod 10 counter must also work as mod 3 when the mod 2 counter is reading 1. First of all, we must see how we'll be designing of a mod 3 counter. As we can see, the number 3 in binary is 11, so our NAND gate will be connected to the last 2 flip-flops of the circuits. Then this will be restarted when it reaches 2. Now, to achieve that our clock restarts at 1259, we must make a small logic circuit in our last 2 counters. For this, we connect a gate and in the outputs of the last 2 flip-flops of the connector mod 10, this to make our mod 3. Then this gate is connected to another AND, which will also depend on the first output of our counter mod 2. Then this gate is connected to another AND, which will be connected between our mod 10 and our mod 3. Therefore, as the mod 3 depends on the output of the mod 2, this will be only activated when the counter mod 2 is at 1. Therefore, our counter mod 10 will count from 0 to 9 until this is the case. And when it happens, it will count to 1259, and in this way, all the counters will be reset to start at 0. Here we can already see all our counters interconnect to each other to thus perform the behavior of a 12-hour clock. I will put the operation of this in fast motion to observe how the hours advance until the time of the restarts.